Steve here with another video from topic 9. We've been working with measures of spread, and we've got the definitions of standard deviation and interquartile range. Those are really useful, and in activity 9-3 we put those tools to use for us. Okay, so what we've got here, what we're showing is 5 different classes and their distribution of scores on some quizzes, right? So think of these scores as possibly running from 1 to 9, and then the distribution is how the different classes performed on the quiz. Okay, so the first thing to do, if you haven't done it already, is to look at these 5 distributions and decide for yourself which one has the most consistency or the least spread. Okay, so you found the most consistent class, okay, at least what you think, right? And then do the opposite. Find the data set or the distribution that you think is the most inconsistent, okay, or has the greatest spread, all right? Okay, right, just jot those down off to the side, right? And then what we can do is we can use our quantitative tools, the standard deviation and the interquartile range, to actually measure these, right? And so then we'll be able to answer the question, which data set is most consistent, which data set is least consistent, okay? All right, so we're gonna have to do some calculations here, but we're not gonna do them by hand. We're gonna let technology do it for us, okay? But one thing I did wanna mention is that, you know, we have the data table that's given to us. And I want you to be really careful reading that table, all right? So here's the table, right? And it's a tally table, right, representing the same information that's contained in the dot plot, okay? And I want to be careful, right? So what these things mean. So let me switch over to something I can write on more easily. Okay, a little harder to read. Okay, but when we look here and I'm looking at class F, okay, here's the dot plot for class F, all right, so one person scored a 1, that's the 1 dot, and then 3 people scored a 2, and 1 person scored a 3, and 5 people scored a 4, right, and so on, right? So if we were actually to make a list of the data, it's going to look like 1, 2, 2, 2, 3, 4, 4, 4, 4, 4, and so on, right? And we notice there's 26 total observations. So there's 26 dots, right? And that's our data set. So if I'm doing this, I obviously don't want to do it by hand, although I could. But if I was doing it even using technology, this is the information that I have to plug into my calculator or into Desmos if I'm using using that app, right? And then calculate the standard deviation or the interquartile range that way. All right, I'm not going to do that. I'm going to use a spreadsheet tool today just to make my life a little bit easier. Okay, so there's all kinds of ways you can do it. Other apps for doing it, but I'm just going to use Excel. All right, so I'm going to kick back to my display here, and then okay, the data set. So I'm on our activities page for the week. Okay, we're working on the value of statistics. The data file we're looking at is the values FJ data file. So I'm going to grab that. I'm going to click on that. I'm going to open it. Okay, there's no viruses in this. I'm going to enable it. Okay, and then here's our data set, right? There's our class F data set. Okay, now, as I said, I can do this by hand or with a calculator, or I can plug these numbers into Desmos if I want. I'm just going to let my calculator do it. No, I'm going to let Excel do it for me. Okay, so what I'm going to do is I'm going to insert a new column. Okay, and I'm going to let I'm going to let Excel find me my quartiles, Q1 and Q3. All right? And here's how to do it. Right? I'll just say equals quartile, and then I have to tell it what array to look at. This is my array. I'm going to grab that. And then comma, and looking for the first quartile. There it is. So Q1, my lower quartile is 4. Let me boldface that. Okay. My upper quartile equals quartile. Give it the array, comma 3. My upper quartile is 6. And so my IQR is going to be the difference between those two things. So it's going to be that cell minus that cell. 2. Boldface that. Right, and then standard deviation, we can do that all in one fell swoop. All right, I'll say equals STDEV. We want STDEV.S, the sample standard deviation. Okay, and then give it the array. And there it is. So 1.95-ish is our standard deviation. Okay, so those are our two measures of spread for the class F data set. It's 2 is the IQR, and the standard deviation is 1.95. All right, so let me enter that. Okay, back to something I can write on. Okay, so my IQR was 6 minus 4, or 2. And my standard deviation was 1.95. Okay, now I'm going to let you do the others. Okay, you should make sure you can using whatever technology you like. Class G also was 6 minus 4 for the IQR, or 2. The standard deviation for Class G was 2.04. For Class H, the IQR is 0, and the standard deviation is 1.18. For Class I, the IQR is 8, and the standard deviation is exactly 4. And for Class J, the IQR is 7 minus 3, or 4. And the IQR is 4, and the standard deviation is 2.67. Okay, approximately. Okay, so here we go then, right? Remember, with our measures of spread, the larger the measure, the more inconsistent the data set, and the smaller the measure, the more consistent the data set is. Okay, so according to this, right, the data set with the smallest IQR is H, right? And H also has our smallest standard deviation, right? So this is our most consistent data set. Okay? That's maybe not surprising, right? Most of the values are the same, right? Most students scored a 5 on the quiz, right? And we know the mean is 5, okay? And remember, the standard deviation sort of measures how far the values are away from the mean, and most of the values have no deviation from the mean, so that tells us why our standard deviation is small. Okay? Right. On the other hand, which class had the largest values for the spread? Right? Class I had an IQR of 8 and a standard deviation of 4. So that's our least consistent data set. Right. Again, that should make some sense, right? So the data is very spread out, right? Students scored either very well or very poorly, right? Our mean is still 5, but there's a lot of deviation from that mean, either on the high side or the low side, right? Okay. So a couple other things to note, right? It might be a little surprising, right? Look at our second most consistent data set was actually class F, right? This data set. This is actually a pretty consistent data set, right? The values are generally pretty close to the mean, right? It doesn't matter that the data set is very bumpy looking, okay? That's not a measure of how spread out it is, okay? In fact, look at class J over here. Class J, okay, it's a uniform distribution, very flat, but there's lots of values that are pretty far from the center, right? And so it has a fairly large IQR and standard deviation. Okay, so the smoothness of your distribution, if it's a frequency distribution, does not tell us about the spread. Okay, we really want to be thinking of how far the data is from the mean. All right, great.